Okay, so here's sine and inverse sine. Notice that the domain becomes the range. Notice that the range here becomes the domain here. And so, if you look at that list I gave you the other day, you should know what sine's domain and range are, cosine's domain and range, and tangent's domain and range. Would you please, in your notes right now, see if you can recreate them. If you need to draw pictures, go ahead. Just don't look in your old notes. I know. They're there. I'll tell you in just a minute what they are. I want to see if you can do it right now. I just told you one of them. I'll pause for a second while you work on that. Okay. So on this, it's -1 to 1. Just showed you that one 2 seconds ago. And if I were you on the test and thinking this through, I'd think, okay, inverse sine, what does that depend on? Sine, of course. So if I knew what sine's domain and range were, remember I only took this part of sine. What was its domain? From here to here, and that was -pi/2 to pi/2. And that becomes the range of this one. Whatever this one's domain was, becomes that one's range. And then what was its range? From -1 to 1. So its domain would be -1 to 1. Get what I'm doing there? So think of each function and the parent of it. This inverse cosine came from cosine, of course. And cosine's graph starts at pi, goes down low, and it has to stop there. So that's the only zone I can use for cosine. That goes from 0 to pi. And from -1 to 1. So this goes from -1 to 1 and 0 to pi. Get that? If you can go back to drawing the little picture of the parent one and knowing what its labels were, then you can answer the inverse. So what does tangent look like? Here's tangent. Here's its parent. Goes from -pi/2 to pi/2. Then I know tangent has no limits when it comes to its range. See, it can go forever this way and this way. So inverse tangent's domain is from -infinity to +infinity. And on the original, the domain was from here to here. So now the range is from here to here. All right, if you didn't have those memorized, I'm going to move to the slide that's got them written very cleanly and neatly. Make sure you memorize those or know how the pictures look so you can reconstruct them. Because you could just simply be asked, what is the domain of inverse cosine? And you'd have to answer what it is. Or it might be more subtle. In the middle of a problem, you could be asked to do something that's impossible. For instance, if I asked you to do the cosine of 7 right there, it can't have a 7 right there because you're only allowed to have between -1 and 1. Tangent, you'll never have a problem here because the domain of it is anything. But if the output of a tangent, like inverse tan of something, is coming out to 90 or 180 or pi, that's not allowed because tangent's only allowed from here to here. So this would be undefined, for example. All right. Next topic. Remember, when you're over there, are all the sides positive or negative, or are they all positive or all negative or some negative? What's the deal? Some sides are negative. So how about this one? Is this negative or positive? How about that one? Negative. How about this one? What can you say about hypotenuses? Always positive. Good. All right, so let's say I had sine is equal to -1/2. Could it be in that triangle right there where sine of something is equal to -1/2? Have I got the triangle right? Why not? Why can't I have it there? It's got a negative side in it. Sine's always positive here. If you think about it, this side right there is positive. It's this side right here that's negative. And so if I'm doing sine is the opposite over hypotenuse, it would be this one over this one, and those are both positive. That's why sine's positive there. So if I want this problem to be answered, this red one here, then I need to draw it down here or over here. Both of those would have negatives in the right spot. Because see, sine is positive here and here. So it can't work there and it can't work there. If sine's going to be negative like this, it has to be one of those two. Okay, just want to remind you about that because it's one of the hardest things for kids. That is not 45. What is that? It's negative 45 or positive 315. Okay, good. Next thing. Is that possible or not? Is inverse cosine allow numbers like that right there? Nope. Has to be between what? Negative 1 and 1. And that's outside the zone. Therefore, undef. And if I was on the test, I'd have to explain why. And I'd say outside of domain. All right, next one. This is the ranges now. This is just a pictorial way of seeing the ranges. Cosine goes from here to here. Let me show you what I mean. If I go back to this slide, here cosine, you know, goes from 0 to pi. And tangent and sine are both the same as each other, see? They go from negative pi over 2 to pi over 2. So that pictorially looks like this. Sine and tangent are over there on the right side, and cosine goes over the top. This is where it's allowed. So if they ever asked you for the answer to on a inverse cosine to come out to like something down in here, not going to work. It's undefined. Is this one okay? The first thing you should ask is it allowed? Is it within its domain? Yep, between negative 1 and 1 is okay. And does negative 1 itself actually work? Yes. Because why? Because sine actually touches negative 1. So inverse sine would also. Not on this problem, but on this part right there, yes. The only ones that don't have brackets on tangent in both directions. Tangent always has only parentheses. All the rest of them, all brackets. Okay? All right, so back to this one. So if it's allowed, then what's the fast, simple way to do this one? And it's the right answer. Remember how these two cancel? So what's the answer? Negative 1. If you wanted to start on the inside, figure that out as two sides, make a triangle, then do the sine of that, you'd still end up coming with a negative 1. It's going to save you a lot of time to know these cancel. So the answer is negative 1. Okay, moving on. That one. Allowed? Yes. Does it immediately give you the right answer by canceling the two things? No. Because these two don't cancel each other. So in that case, you start on the inside. Would you please draw me a picture, it doesn't necessarily have to be a triangle, that would make that blue thing. Not make it disappear, just make a picture for what I circled in blue. I can make it disappear. All right, what you should be thinking is, all right, this is the kind that inverse sine, that means that this is actually sides right here. So I'm going to put it over 1, that way I have two sides. But then you should realize that if sine is opposite over hypotenuse, I've got two sides that are the same length. Is that possible in a right triangle? To have the opposite and the hypotenuse be the exact same length as each other? No. The hypotenuse has always got to be longer. And therefore, I'm at a special spot that's not a triangle, which means I'm either here, 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 or here. As soon as you realize I can't draw a triangle for this, then you're at one of those spots. And for these spots, you've got to know these points. 1, 0. What's this one? 0, 1. What's this one? Negative 1, 0. And last one? 0, negative 1. And now I ask you, which one is sine? The x or the y? So we're looking for where y is negative 1, and that would be right there. And therefore, the answer is whatever that is. And I know what that one is. I have it memorized. It's 270. Now, cosine of 270. Well, that's easy if you think about it too, because I've already got this all drawn out. Sine was the y. What's cosine? It's the x. And no, therefore, it's 0. All right. I think we did that one before. Skip ahead a bit. Can I cancel those two inverse signs? Sine and inverse sine? Yes, because this is okay. It's in the domain. All right. Now, there's one more kind of problem I got to show you, and it looks kind of like this one. It's the first problem of the homework. So I'm just going to show you how to do this by doing a couple homework problems with you. So get up to a blank sheet where you could start your homework for today. And now, why is this different than what we have done every other time? Because in the past, I'd always give you an angle, or I'd give you the sides, and this one I didn't give you either one. Now think about this. This right here should be sides, because whenever they got a little -1 like that, they want you to figure out the angle. So they told me the sides. I'm going to put it as an x over 1, that way I know I got two sides. Take a wild guess what shape you're going to draw next. A triangle. So everybody draw me a triangle, like this. And then the angle for it always goes here, and if we don't know it, we put a theta. And now, if I know sine is x over 1, don't I know then that this is x and this is 1? Do you get that? Sine is the opposite over the hypotenuse, right? Then, do you get that whatever this side is right here, I don't know what it is, I'm going to call it n, could be made up of, figured out by using a squared plus b squared equals c squared? You remember that? That this squared plus this squared has to equal that squared? Know what I'm talking about? So I can figure out that third side. This is the new stuff that you haven't done before. All right, so if I call this n, I'm going to say n squared plus x squared has to equal 1 squared. And then solve for n. Try it right now. This is just basic algebra. 1 squared is 1. Yes, you can replace it with a 1. Get the n alone. Do it on the paper. Use your brain, not mine. I don't think you had this. Did you have a problem like this on Friday? I don't think so. Oh, okay. I'm sorry. There's a problem exactly like this. That's problem 47. That's what you're going to be doing. This is what you're going to be doing. Don't worry. Before, you're right. We asked you about what's this domain and range of this, but we didn't actually ask you to figure out the triangle and everything for it. Okay. Did you figure out that n squared equals 1 squared, which is just 1, minus x squared? Did you get that far? And then did you get the n completely alone by taking the square root and saying square root of 1 minus x squared? That's the right answer. So what did we just figure out? We just figured out that this side right there is really the square root of 1 minus x squared. Now what's cool about that? What they're going to ask you is for, okay now, what's cosine of that? Well, if I've got all the sides, it's really easy to do cosine of that. Cosine would be adjacent over hypotenuse. If I wanted tangent, it'd be opposite over adjacent. I would just write down x over square root of 1 minus x squared. All right, so I know this triangle you just drew right there and that side there are going to be handy. I just got to figure out which one it is that's going to be handy on. That's going to be problem 49. So relabel this one, you guys, as 49. Sorry, of today's homework. That's how you'll. That's how you'll start. You'll draw that triangle. You'll figure out this side here. And then they ask you on 49 to do what's the tangent of that. Well, once I got this triangle drawn, to do the tangent of it is super simple. Tangent's opposite over adjacent. So what is tangent of that angle? X over square root of 1 minus x squared. The answer I have circled for you. Now let's go back and do a different one. It's okay if your assignment's in a different order. Everybody else will be the same in the room, so you'll be fine. Problem 47 is what we were really going to start with for today. So find some room to do problem 47. And it says it in a little different way. It says sine of inverse tangent of x. I've tried to repeat this so many times that you will know it automatically. Where do you start in a problem like this? On the inside. Once you start on the inside, what shape do you think you're probably going to draw? A triangle. Except this time, we don't know where the x is automatically. You got to think about it. Tangent is opposite over adjacent. The x is over here, but the hypotenuse is not 1. Tangent is opposite over adjacent, so where does the 1 go? On the bottom. And now use a squared plus b squared equals c squared. To get this side, it's always going to be a square root of. So, what do you think it is? This one's a lot easier than the last one. 1 plus x. I could say 1 squared plus x squared, but 1 squared is 1, so. All right, now I got my triangle. It'll be easy. Now I can go to the outside and look sine of that. I don't even need to know what this angle is. I can't know what it is. I don't know it's like 37 degrees. But I know that I can say sine of it because I got these things to give me sine. Sine is opposite over hypotenuse, right? So once I got my triangle drawn, I just have to go, okay, well, sine of this angle then, sine of theta, must be opposite over hypotenuse, which would be x over square root of 1 plus x squared. All right, one little gotcha that comes up I want to make sure you get is if you end up with a triangle that's got like this, this other side is, I told you it's always a square root, but what do you think a lot of people write? Just say the answer really quick. What do you think it is? 2x, what? 2x squared plus 1. Why is that wrong? It's really close. 4x squared. Do you get, you have to square this, which means you square the 2 and you square the x? Did you know that about squaring? So it's 4x squared plus 1. Just be careful on that. You're going to have one of those. Okay? All right. So we did 47. Let's just do one more. We'll do number 48. Problem 48 says cosine of inverse tangent x. Does that look familiar? Isn't it exactly the same triangle as problem 47? Still a tangent. Tangent is opposite over adjacent. Opposite, adjacent, x1, and then this must be, what? X squared plus 1. And then I want the cosine of that. Ah, so it's the same exact triangle I had last time, and I just got to do cosine. Cosine's adjacent over hypotenuse. From there, if you can't do it, I probably can't help you. Because it's pretty simple from there. All right. So your homework for tonight is problems 47 through 52, of which we've already done 3 of them. And then there's a little review section, which is problems 57 through 67. That's just a review section, some of which are multiple choice. So it's not too rough tonight. Number 33 was actually similar to problem 49. Remember I changed 33 to 49? I don't know if you caught that. So if you've done 33, change it to a 49. Okay, are there any other things? Oh wait, I didn't say what page. It's page 421. All right, so now you have 15 minutes left in class, which is cool. So you have time to work. Grab a book, please. Leave a shoe or a cell phone. Share one if you can. If you've got somebody you like, please share a book because I don't have quite enough for everybody. All right.